Lesson 1.4 from our BGU Geometry textbook. This lesson is a framework with definitions. So we're building our framework of geometry with some very important and basic definitions that will help us define all the other definitions and theorems and postulates as we go. So we're going to identify the structure of a postulate system, and we're going to define key geometric concepts, and then also define postulate and theorem. So we learned in the last lesson these things called undefined terms. And those are terms that did not have a definition, they could only be described. And we said that those were the building blocks of all of our other definitions. So definitions are built upon undefined terms. Well, then we can take those definitions and create postulates, and then from those postulates we can build theorems. So postulates are things that we know to be true, where theorems are things that we have to prove to be true. So let's take a look at our first definition. This is called collinear points. So collinear means points that lie on the same line. So for example, points A, C, and F are collinear points because they all lie on line K. Non-collinear points are points that do not lie on the same line. So for example, points W, X, and Y are non-collinear because no line contains all three of them at once. Concurrent lines are lines that intersect at a single point. So concurrent lines are lines that intersect. Concurrent, intersect, right? Concurrent lines are lines that intersect. So lines A, B, and C are concurrent because they all intersect at point P. Next, we have the definition coplanar points. So that word co, again, means on the same, right? And we're talking about planar, so we're talking about the same plane. Coplanar points are points that lie on the same plane. So for this example, points A, B, and C are coplanar because they all lie on plane Q. So like coplanar points, we have something else called coplanar lines. So similar to coplanar points, coplanar lines are just lines that lie on the same plane. So for example, lines M and N are coplanar because they both lie on in plane K. So now we have a definition of parallel lines. Parallel lines are coplanar lines, so they have to be in the same plane. However, they do not intersect. If lines L and M are parallel, we can write it with the symbol of two vertical lines. So L is parallel to M. So that symbol is read is parallel to. Then we have something called skew lines. Skew lines are lines that are not coplanar, so they are not in the same plane. So lines L and lines M are skew lines because there's no plane that contains both of them at the same time. So even though line L goes through line K, line L is not on plane K, and line M is on plane K. So L and M are skew lines. Then we have a definition of parallel planes, and those are planes that do not intersect. So for here we have planes K and S are parallel. And so again, we can use that parallel symbol, so it would be read plane K is parallel to K and S. So if we can have a statement that is shown to be true by logical progression of previous statements, previous terms, and definitions, we call that a theorem. So a theorem is a statement that is shown to be true by a logical progression. The process of justifying a theorem is called proving, or proof of a theorem. Postulates, which we also called axioms, are assumed to be true. We don't have to prove them using previous theorems and previous terms. Postulates are already assumed to be true. Theorems have to be proven from definitions, postulates, and previous theorems. And that's all for this lesson. Make sure that you check and see what problems you have to do along with these video notes.